Welcome back. We looked at electron configurations, or not electron configurations, orbital diagrams. Today we're going to look at electron configurations, which are actually very similar. In your orbital diagrams, you are showing where all the electrons are scattered throughout the atom, in which shaped orbital, S, P, D, or F, and you are showing how many orbitals are present. You are showing that the electrons are spinning in two different directions, meaning like oppositely, by showing different arrows. And they get kind of long, they get kind of drawn out. And I've said a few times already that chemists are fairly lazy. We don't want to write extra information unless we have to. So obviously, there is a shorter way to write these. Orbital diagrams are necessary when you actually want to see all of the different orbitals that are present, when you want to see how the electrons are spinning, where they're scattered, things like that. In order to kind of bring it down a notch, instead of showing all the electron spins, all the different arrows, what we're going to do is we're going to leave those out. And instead of saying, hey, we have 8 electrons in the 3D orbital, we're just going to write the number 8. So instead of going through and putting down like 3D, a D has 5 orbitals, so you would draw 5 lines, and then you would take your 8 electrons and put the arrows spinning up and down in different directions while you're spreading them out first and then doubling them up. We're just going to write down the number 8. And this says that in the 3rd energy level, D-shaped orbital, so a cloverleaf shaped, there are 8 electrons here. So all we're doing is we're taking away the arrows and we're writing down, hey, I would have written 6 electrons here, or 6 arrows. I would have written 4 arrows here, or however many you needed to write. So I have a few examples that we're going to do on these. We have nickel and we have aluminum. I'm going to switch over to my document camera. And here I have the periodic table that we colored with the orbital diagrams. And we said that if we have an s orbital, each orbital holds 1 electron. And with that 1 electron, we have those, or not 1 electron, each orbital holds 2 electrons spinning in 2 different directions, so that one line, 1 orbital holds 2. So instead of writing that one line with your 2 electrons, we would just write 2 if it's full. If we have a p, there's 3 orbitals present. Each orbital holds 2 electrons. So on our p, I'm struggling, sorry. We would write 6 if it's full. D, we had 5 orbitals. For those 5 orbitals, it holds 10 electrons. 2, 4, 6, 8, 10. And then F was down here kind of at the bottom. It's underneath my picture. But if you have an F, there was 7 orbitals, so that holds 14 electrons. And if you actually count across the S block, there's 1, 2. Hey, S is 2. If you count across the 6, 1, 2, 3, 4, 5, 6, P holds 6. The D, if you count across here, 2, 4, 6, 8, 10, D holds 10. And then F holds 14, 2, 4, 6, 8, 10, 12, 14. So everything follows the periodic table for what we're going to do. So on our examples, we had aluminum, and then the other example that we had, I think, was chromium. Let me go back. Nickel. So we have nickel and we have aluminum. I'm actually going to do aluminum first, and then I'll go back and I'll do nickel. Write that down so I remember. But the process is very similar. You always start up here with hydrogen. When you start with hydrogen, or in the 1st energy level, this is the S block. When you write down 1s, we're going to write down 1, 2 electrons. So we have 1s, 2. So there's my 2 electrons. Then the next row, I'm at 2s, 1, 2. After 2s2, I come down here and I'm at 2. This is the P block. Going all the way across all of these, so it's 2p6. Then after that, I'm at 3. This is the S block, 1, 2. After 3s2, this is where aluminum lives. So I'm going to write down 3 because I'm in the 3rd energy level. This is the P block, so I'm going to write down P. Now I start at the beginning of 3P and I just count over till I get to aluminum, 1. So 3P, 1. So if we look at this, we have 2 plus 2 plus 6, that's 10, plus 2 plus 1, that gives us 13 electrons. Aluminum is number 13 on the periodic table. So actually everything all goes together and makes sense. Now the next one that we have is nickel. Again, with nickel, right here, we're going to go through the periodic table, and we again have to start with hydrogen up in the top corner. We're going to keep reading left to right until we get to nickel. So hydrogen is 1s. With hydrogen being 1s, let me fold this back real quick. There we go. We're going to count over 1, 2 electrons. Then in the next row, I have 2s. 1, 2. The next number that I see is 2p, and that's 6. 1, 2, 3, 4, 5, 6. After 2p6, I'm at 3s2. 1, 2. 3p6. Going all the way across all those. Now 4s. 1, 2. Now this is 3d. 3D is where nickel lives, so I start at the beginning of 3D and I count over till I get to nickel. 1, 2, 3, 4, 5, 6, 7, 8. So nickel is 3D8 is where it ends. So if we added up all the electron numbers, we should get 28. The 1 tells me the energy level. These two are both in the second energy level. Third energy level with these down here, even though they're split up, they're all in the third energy level. And then my highest energy level, my highest orbital, is the fourth energy level. So as we write these out, we're just taking away the arrows. It's the same process that we did with orbital diagrams.